NEC Section 230.71 addresses the readily accessible location of the service disconnecting means. The service disconnecting means must be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. This code requirement is intended to ensure that the service disconnecting means can be easily and quickly accessed in case of an emergency. In the given scenario, there is a debate about whether the 200 amps main circuit breaker in the panel meets the requirements of NEC Section 230.71 or whether the disconnect should be part of the meter pan. Camp B's argument, which favors locating the disconnect at the meter pan, aligns more closely with the intent of NEC Section 230.71. The code stipulates that the service disconnecting means should be installed at a readily accessible location near the point of entrance of the service conductors. In this situation, the service conductors enter the basement and run 5 feet to the new panel. However, the panel isn't located at the point of entrance of the service conductors, nor is it readily accessible due to the presence of the water meter, sump pit, and central vacuum system in the area. Camp A's argument, suggesting that the 200 amps main circuit breaker in the panel satisfies NEC Section 230.71, isn't fully supported by the code. While the main circuit breaker serves as a disconnecting means, it doesn't qualify as the service disconnecting means. A service disconnecting means is defined as a device that disconnects all ungrounded conductors of the service from the premises wiring. The 200 amps main circuit breaker only disconnects the ungrounded conductors of the panel from the rest of the premises wiring. Therefore, the ideal solution would involve installing a service disconnect at the point of entrance of the service conductors. This can be achieved either by using a meter pan equipped with a service disconnect or by installing a separate service disconnecting means adjacent to the meter. Several factors contribute to determining the appropriate location for the service disconnect. Firstly, consider the point of entrance. The code prioritizes placing the disconnect as close as possible to where the service conductors enter the building. Secondly, accessibility is crucial. The disconnect must be readily accessible, meaning it shouldn't be obstructed or require tools to operate. Thirdly, safety is paramount. The location should minimize risks and ensure safe operation during emergencies. Consider the specific layout of the building and the location of other utilities. Ensure that the service disconnect is installed in a location that minimizes interference with other systems and provides adequate clearance for maintenance and operation. Additionally, local codes and regulations may impose further requirements regarding the location of the service disconnect. Always consult with local authorities to verify compliance with all applicable codes. In summary, the service disconnect should be installed at a readily accessible location nearest the point of entrance of the service conductors, taking into account accessibility, safety, and local codes. Now let us consider the specifics of what readily accessible really means. Readily accessible is defined in Article 100 of the NEC. It means capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. This definition is critical in determining whether a location meets the code requirements. In the scenario presented, the presence of a water meter and filtering system, a sump pit, and a central vacuum system creates an obstruction that might make the panel not readily accessible. Framing out this area and sheetrocking it with only one doorway could further impede ready access, especially in an emergency. Consider the working space requirements specified in NEC Article 110.26. These requirements dictate the amount of clear space needed in front of electrical equipment to ensure safe operation and maintenance. The depth of the working space depends on the voltage to ground and the condition of the installation. Condition 1 exists where there are exposed live parts on one side of the working space and no live or grounded parts on the other side of the working space, or where exposed live parts are on both sides of the working space that are effectively protected by insulation or other means. Condition 2 exists where exposed live parts are on one side of the working space and grounded parts are on the other side, but the grounded parts are effectively grounded. Condition 3 exists where there are exposed live parts on both sides of the working space, and those parts are not effectively protected by insulation or other means. The depth of the working space for voltages of 150 volts to ground or less is 3 feet for condition 1, 3 feet for condition 2, and 3 feet for condition 3. The depth of the working space for voltages of 151 volts to 600 volts is 3 feet for condition 1, 3.5 feet for condition 2, and 4 feet for condition 3. The width of the working space shall be the width of the equipment, or 30 inches, whichever is greater. The height of the working space shall be 6.5 feet, or the height of the equipment, whichever is greater. Ensuring adequate working space is essential for safety and compliance with the NEC. Regarding the installation of a meter pan with a service disconnect versus a separate service disconnecting means, several factors should be considered. A meter pan with a service disconnect combines the metering equipment and the service disconnect into a single unit. This can save space and simplify the installation. However, it may also limit flexibility in terms of placement and maintenance. A separate service disconnecting means provides greater flexibility in terms of placement and maintenance. It allows the metering equipment and the service disconnect to be located independently of each other. However, it may require more space and increase the complexity of the installation. The choice between these options depends on the specific requirements of the installation. Considering potential future modifications or expansions is crucial when deciding on the location of the service disconnect. If there is a possibility of adding more circuits or equipment in the future, the service disconnect should be located in a place where it can accommodate these changes without requiring significant rework. Moreover, ensure that the service disconnect is protected from physical damage and environmental factors. It should be installed in a location where it is not exposed to moisture, corrosion, or mechanical stress. The enclosure should be suitable for the environment in which it is installed. The NEC also addresses the rating of the service disconnecting means in section 230.82. The service disconnecting means shall have a rating not less than the calculated load to be carried. This ensures that the service disconnecting means can safely handle the expected load without overheating or failing. In addition to the rating of the service disconnecting means, the overcurrent protection devices must also be properly sized and coordinated. The overcurrent protection devices should protect the service conductors and equipment from overloads and short circuits. The NEC provides detailed requirements for overcurrent protection in Article 240. Let's examine some examples of how these principles apply in different scenarios. In a small residential building, the service conductors enter the basement, and the electrical panel is located on the opposite side of the basement. In this case, installing a service disconnect at the point of entry in the basement would be the most compliant solution. This ensures that the disconnect is readily accessible and close to the point of entrance. In a larger commercial building, the service conductors enter the building in a dedicated electrical room. The electrical panel is located on a different floor. In this scenario, installing the service disconnect in the electrical room near the point of entry would be the appropriate approach. This keeps the disconnect readily accessible and separate from other equipment. Consider the impact of emergency conditions on the location of the service disconnect. In the event of a fire or other emergency, firefighters or first responders may need to quickly disconnect the power to the building. This service disconnect should be located in a place where it can be easily found and operated in such situations. Clear signage and labeling can help to ensure that the disconnect can be quickly located in an emergency. In addition to NEC requirements, local utility regulations may also dictate the location and type of service disconnect. Utility companies often have specific requirements for the placement of metering equipment and disconnects. These requirements may vary depending on the utility company and the region. Always consult with the local utility company to ensure compliance with their regulations. Regarding the grounding and bonding requirements, the service disconnect must be properly grounded and bonded to ensure electrical safety. The grounding electrode system must be installed in accordance with NEC Article 250. The metal enclosures of the service disconnect and other electrical equipment must be bonded together to create a low impedance path for fault currents. Proper grounding and bonding are essential for protecting people and equipment from electrical shock. Consider the potential for future upgrades or changes to the electrical system. The service disconnect should be located in a place where it can be easily accessed and modified if needed. This may involve providing extra space around the disconnect or installing it in a location where it can be easily expanded. Planning for future upgrades can save time and money in the long run. Let's discuss the specific products and equipment that can be used for service disconnects. Meter pans with the integrated service disconnects are available from various manufacturers. These units combine the metering equipment and the service disconnect into a single enclosure. They are typically used in residential applications where space is limited. Separate service disconnect switches are also available from various manufacturers. These switches can be used in both residential and commercial applications. They come in a variety of sizes and ratings to accommodate different load requirements. When selecting a service disconnect switch, consider the voltage and current rating, the enclosure type, and the operating mechanism. The switch should be rated for the maximum voltage and current that it will be subjected to. The enclosure should be suitable for the environment in which it will be installed. The operating mechanism should be reliable and easy to use. The NEC also addresses the requirements for surge protection in Article 230.67. Service equipment installed in dwelling units must be provided with surge protection. Surge protection devices can help to protect sensitive electronic equipment from damage caused by voltage surges. These devices should be installed at the service entrance to provide maximum protection. Let's consider the differences between using a fused disconnect versus a non-fused disconnect. A fused disconnect provides overcurrent protection in addition to disconnecting the power. It uses fuses to protect the circuit from overloads and short circuits. A non-fused disconnect only provides a means of disconnecting the power. It does not provide overcurrent protection. The choice between these options depends on the specific requirements of the installation. In some cases, a fused disconnect may be required to provide adequate overcurrent protection. Remember to consider the coordination between the service disconnect and other disconnecting means in the electrical system. The NEC requires that all disconnecting means be properly coordinated to ensure that the system can be safely de-energized in an emergency. This involves selecting the appropriate types and sizes of disconnecting means and ensuring that they are properly labeled. We should also discuss the importance of regular maintenance and inspection of the service disconnect. The service disconnect should be inspected regularly to ensure that it is in good working condition. Any damaged or worn parts should be replaced promptly. The connections should be checked to ensure that they are tight and secure. Regular maintenance can help to prevent problems and extend the life of the service disconnect. Finally, always consult with a qualified electrician when installing or modifying a service disconnect. Electrical work can be dangerous, and it is important to follow all applicable codes and safety precautions. A qualified electrician has the knowledge and experience to safely and correctly install or modify a service disconnect. Consider the potential for future changes in the NEC and other electrical codes. The electrical codes are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest code requirements to ensure compliance. Continuing education and training can help to keep you informed about changes in the electrical codes. Also, reflect on the importance of documentation and record keeping for the service disconnect. Accurate documentation of the service disconnect installation, including the location type and rating of the disconnect, can be valuable for future maintenance and troubleshooting. These records should be kept in a safe and accessible location. Discuss the potential impact of energy efficiency considerations on the location of the service disconnect. In some cases, locating the service disconnect in a more accessible location may improve energy efficiency by making it easier to de-energize circuits when they are not in use. This can help to reduce energy consumption and lower utility bills. In addition to the NEC, other industry standards and best practices may provide guidance on the location of the service disconnect. Organizations such as the Institute of Electrical and Electronics Engineers, IEE, and the National Fire Protection Association, NFPA, publish standards and guidelines that can be helpful in designing and installing electrical systems. Let's explore the potential for using remote monitoring and control systems for service disconnects. Advances in technology have made it possible to remotely monitor and control service disconnects. These systems can provide real-time information about the status of the disconnect and allow it to be remotely operated. Remote monitoring and control systems can improve safety and efficiency by allowing for quick response to emergencies and reducing the need for manual operation. Remember that the service disconnect is a critical component of the electrical system and must be installed and maintained in accordance with all applicable codes and regulations. Proper installation and maintenance can help to ensure the safety and reliability of the electrical system. The service disconnect should be located in a place where it is easily accessible to authorized personnel but protected from unauthorized access. This may involve installing the disconnect in a locked room or enclosure. Preventing unauthorized access can help to prevent tampering and vandalism. Consider the impact of environmental factors on the location of the service disconnect. The service disconnect should be protected from extreme temperatures, humidity, and other environmental factors that could damage the equipment or impair its performance. The enclosure should be suitable for the environment in which it is installed. Let's explore the potential for integrating the service disconnect with other building systems. In some cases, it may be beneficial to integrate the service disconnect with other building systems, such as the fire alarm system or the building automation system. This can allow for coordinated response to emergencies and improve overall building safety. Lastly, always prioritize safety when working with electrical equipment. Electrical work can be dangerous, and it is important to follow all applicable safety precautions. Wear appropriate personal protective equipment, use insulated tools, and de-energize circuits before working on them. Safety should always be the top priority.